Yes, good afternoon to all of you. Students, can you hear me? Okay. Can you see the slide? Okay, that's good. So students are joining little bit late. I hope that those students who are remaining, they will join in very short time. Meanwhile, before I start for today's lecture, anybody recollect what was covered in the previous lecture? Okay. So in a previous lecture, we discussed some points related to the modular arithmetic, additive inverse, multiplicative inverse. Okay, we did some examples related to modular arithmetic, then additive inverse was discussed, and we had seen some examples, and multiplicative inverse was also discussed. So additive inverse, the condition is that a plus b congruent 0 mod n, right? The sum of an integer and its additive inverse is congruent to 0 mod n. Okay, and multiplicative inverse, the multiplication of a cross b is congruent to 1 mod n. That is multiplicative inverse, right? So an integer may or may not have multiplicative inverse, right? So if 3 is the number integer, then its multiplicative inverse is 7. Why? Because 3 into 7 mod 10 is 1, right? Then I ask you to solve this. Multiplicative inverse of 8 in Z10 is not possible because when you take GCD of 10 and 8, it is not 1. But for all multiplicative inverses of 10, Z10 and Z11, they were discussed. The integer, then we had seen this theoretical proof that an integer a in Zn has a multiplicative inverse if and only if GCD of Na congruent to 1 mod n, right? So we had seen that a inverse n equal to t and t inverse mod n is equal to a. So a and t are multiplicative inverse of each other. And then I ask you to solve this problem on your own, right? The multiplicative inverse 11 of 11 in Z26, right? So how many of you have done this multiplicative inverse of 11 in Z26? What is the method for that? What is the method for that? Can anyone say the answer? What is the method of finding multiplicative inverse? In online mode, we don't know whether you are there or not. So you have to respond, then only we will be able to know it. A cross B mod n, but method is apply extended Euclidean algorithm. I have written here, apply extended Euclidean algorithm. So by applying extended Euclidean algorithm, if you get GCD 1, then multiplicative inverse is possible. If it is not 1, then multiplicative inverse is not possible. Is that clear? Right? So we had seen it in the context of 23. For 23, we found with this extended Euclidean algorithm that multiplicative inverse of 23 in Z100. So R1 is 100 and R2 is 23, right? So with quotient Q, remainder is R. And with this, by applying the same process, finally we get 1. Okay. At that time, what is the value of T1 and T2? And we find that when the GCD is 1, T1 is minus 13. So it means that GCD is 1, it means the multiplicative inverse is possible. And the value of the multiplicative inverse is minus 13. So 23 has multiplicative inverse minus 13. But minus 13 is not in Z100. So minus 13 mod 100, that gives us 87. So 87 and 23 are multiplicative inverses, right? So 87, 23 mod 100 gives us 1. Okay, is that clear to all of you? So for 12, we find GCD to 2, and so its multiplicative inverse is not equal to 1, so it is not possible. Okay, now we will use this multiplicative inverse concept today in our discussions, further discussion. Okay, so today's first topic is multiplicative cipher. See, multiplicative cipher is already discussed in your lab also. So there will be a little bit of revision. But after that, we will take up some one more topic which is not discussed in the lab. But even if it is discussed in the lab, I would like you to pay attention so that in case if your concepts are not clear, then it will help you to clear your concept. So encryption method in multiplicative cipher is P into K mod 26. Decryption is C equal to P into K inverse mod 26. So like in additive cipher, we used to have key added into plain text. Here we have multiplication. But if we used to do addition, its reverse operation was subtraction for decryption. So in multiplications, reverse operation is division, right? So multiplicative cipher, the plain text and the cipher text are integers in Z26. Okay, plain text and cipher text are from Z26. What is the meaning of Z26? Can anyone write in a chat box? Possible key values? 0 to 25. Okay, perfect. Right? Now, the key in Z is 26 star. What is the key domain of multiplicative cipher? What is the key domain of the multiplicative cipher? Can anyone say? Do you remember how to find out key domain? or you may use your mic also if you don't want to type, or you can type also, no issue. Yes, what is the key domain of multiplicative cipher? So what you have written for Z26 is a key domain for Z26. So what is the key domain for Z26 star? Z star where GCD of xn equal to 1. Kaushal, but which values? You are right, but which values you will get this? Take values of Z26. Yes. So some of this Abhi and Rikin, they have posted the values. Rikin has also done, Abhi has also done. Yes, Kaushal? Jeet has also done. Yes. So if we take all odd values except 13, right? 1, 3, 5, 7, 9, 11, 15, 17, 19, 21, 23, 25. If we take all these value, for each of these value, its mod with 26 results into 1, right? So GCD is 1. So 26 and 3, 26 and 7, right? So GCD is 1. And so its multiplicative inverse is possible, right? So we have found all keys whose multiplicative inverse can be found. And these values are total 12 in number, right? In Z26, how many keys are there? Total keys, number of keys? 26. And here there are 12 keys, right? So the key domain is smaller actually. Key domain is smaller, right? In multiplicative cipher, the key domain is smaller. So if you look at this, the encryption algorithm, as you can see, there are two entities, two people. One is Alice and another is Bob. Alice is interested in sending encrypted text to Bob. Okay. So Alice will use this encryption algorithm. C is equals to P into K mod 26, where it will take some K value key. Okay. So this encryption algorithm specifies multiplication of plain text by the key, and the decryption algorithm specifies division of the cipher text by key. Like in additive inverse, we used to have plus and its decryption was with minus. So here, if we take plus, students, any noise you are getting? Are you getting any noise? Okay, now is it okay? Now can you hear me properly? Okay, okay. See what happens that when we have some value, let's say 5 into x, right? So let's say equal to 1. So x is equals to 1 upon 5, right? So what we are doing is we are dividing it, right? Here we are dividing it. Then we are getting the reverse operation, inverse operation. So this is equal to 5 inverse, right? This is equal to 5 raised to minus 1. So that is 1 upon 5. But 5 raised to minus 1, that is 1 upon 5, is not the meaning in inverse, right? Here the inverse is actually referring to division operation, right? So we are supposed to perform division K inverse of the key, right? Key value is, let's say key value is 3. Okay. Then when we perform decryption, for decryption, the key value should be 3 inverse. Okay, 3 inverse, that is inverse of 3, and that too from Z26 star. Okay, so we will get original text. Okay, so what you can see in this decryption algorithm is P into K inverse. P is cipher text. Okay, P is of what? Cipher text. So cipher text multiplied by key inverse mod 26. That is our decryption formula. Okay, so here we are performing encryption, and at Bob end we are performing decryption with K inverse. Right, so division operation is multiplying by multiplicative inverse of the key. Right, so we can say that division is multiplying by inverse of the key. So the key needs to belong to the set Z26 star to guarantee that encryption and decryption are inverses of each other. And that is why we are creating this Z26 star. Okay, we are creating this Z26 star because we want these values, right? 1, 3, 5, 7, 9, right? 11, 15. Why 13 is not there in this? Why 13 is not there? 13 more 26 is 0, right? Correct. That is why. Correct. Right? So 17, 19, 21, 23, 25. Okay. So if we take 3, then its inverse is 9. Is it true? 3, 9 are inverses of each other. Is that true? Three and 9 inverse of each other. Yes or no? Why? Why we can say this? Yes, 3 into 9 is 3 into 9 is 27, and its mod with 26 is 1, right? So 3 and 9 are multiplicative inverse. So we have to take, when we are performing encryption, if we take 3 as a key, okay, then at decryption we have to use 9. That is what we have to remember. Okay. So this is the example. We use multiplicative cipher to encrypt the message hello with a key of 7, right? For 7, the solution is given. Now you use key value 9 and encrypt the plain text. Do this. Do this exercise. For 7, the solution is given. So the same way you perform solution for 9 and give me the answer in the chat box. So what we have to do? 7, 4, 11, 11, 14. Okay, key is 9. So we have to do multiplication. How much? 126. Okay, and then take mod. So what values you are getting? What is the answer of 63 mod 26? 63 mod 26, 11. 36 mod 26, 10. 99 mod 26. 21. 21 and 126 mod 22. Okay, perfect, perfect. Very good. So this results into the ciphertext. What is the ciphertext corresponding to 11, 10, 21, 22, 20? LKVVW. Okay. This is our ciphertext. Okay. Any question, any doubt? Any of you? Those who could solve, it is very good. Those who have any question, you may ask. Very simple, right? So I hope that you are able to do it. Okay, for 7, the encryption is different and that is shown here. Okay, you have to perform this. Now, second method is affine cipher. So affine cipher is a combination of additive and multiplicative ciphers with a pair of key. So what is the total number of keys in Z at 26? In additive cipher, remember, in additive cipher, we use key from Z26. And in multiplicative cipher, the key is from Z26 star. The key domain in the Z26 is 26 and in Z26 star it is 12. We just discussed it in the beginning of the lecture, right? So total number of possible keys, with both keys is equals to 26 into 12. So that results into 360. So we have 360 possibilities. How we can have 360 possibility? Because in affine cipher, what we are doing? In affine cipher, we use two keys, K1 and K2. Okay, we use two keys. So first key is from multiplicative cipher, that is having 12 possibilities, and second key is as additive cipher from Z26. So what happens on encryption side when the allies wants to send any text message or plain text message? So allies applies first multiplicative inverse on the plain text, and then additive inverse is applied. Okay. So in general, we can write it as P into K1 plus K2. Okay. In general, we can write it as C is equals to P into K1 plus K2 mod 26. Okay. So this is the main process on the allies side, that is encryption. So K is here, the K is from Z26 star, and here the K is from Z26. Okay. Then the ciphertext is sent to Bob. Now Bob receives this ciphertext. So what Bob does, it first performs reverse of additive, right? So C minus K2, and then it performs multiplication by multiplicative inverse, right? So plain text can be recovered from by performing this C minus K2 multiplied by K inverse mod 26. Okay, this is the formula. Okay, this technique is known as affine cipher. Okay, now perform this example. Use the affine cipher to decrypt the message with the key pair of 7 2 in modulus 26. What is given to you is ZEBBW. Okay, and you have to perform decryption. What are the key pair values? 7 2. So how will you perform decryption? Okay, please try solve this problem. All of you solve this problem. Okay, Rikin, please write down the steps. Others, please continue. Please do this, solve this example in your book. And if you have any doubt, you can ask questions so that it will be cleared. So text plus additive key, that is not, that doesn't appear to be correct. I think the answer is correct, but the method which you have written, there is a typing mistake. Yes, others, please. Others. Right. So the equivalent value of Z is 25, E is 4, B is 1, and 22. So what we have to do first, we have to subtract key 2, right? So 23, 2, minus 1, and 20. And then multiply it by K inverse, right? K inverse. So what is 7 inverse? That you have to first find. What is 7 inverse? Okay, 7 inverse. What is the method of finding 7 inverse? That is 7 into A mod 26 is equals to 1. This should be the answer. Correct? Yes or no? Right? So we have to take A in such a way that if we take a multiplication result with mod 26, then we get 1 as a GCD, right? Or GCD of uh, 26 and 7, right? GCD of 26 and 7 is equals to 1, right? Because 7 is from Z26 star, right? So this result is correct. So if we try to find GCD of 26 7, right, by applying extended Euclidean algorithm, we can find out this. Correct? We can apply extended Euclidean algorithm, just as we have seen in the earlier class, right? So we have to apply the same 26 7. Then so this is our r, this is r1, this is r2, this is r, t1, t2, and t and q, right? Okay, so finally we will get 15, right? Finally we will get 15. So 15 is going to be our uh, key inverse, k inverse, right? So 23 multiplied by 15. So what is the answer? 23 multiplied by 15, 230, 115, right? 345, right? 345 mod 26. So this results into, what is the answer? 345 mod 26, 7, right? 7 is equivalent to which character? H, right? Right side, perfect. So this way we have to perform decryption for all other characters, and so what answer we will get is hello. The answer is hello. I think some of you could at least do it on your own at your place. I believe in positive spirit that you have done it. Okay. Now, next important part is crypt analysis of affine cipher. Right? How we can perform crypt analysis, because the total number of possible keys are 360. Right? So, is there any other way than the brute force? Because brute force is actually going to take a lot of time. Right? So, what are the possible alternatives? So, here let us see chosen plain text attack. Okay, in this chosen plain text attack, let us assume that Eve intercepts the following ciphertext, right? So long ciphertext is given, as you can see on this slide, that this long encrypted text is given. Now, what is the attacker is supposed to do? Attacker is supposed to find out keys of the affine cipher, okay, to decrypt this text, right? So let us assume that you is an attacker. and Eve has an access to Ali's computer, right? See what happens is when the attacker, right? So there is an Ali's computer is there. Now what Eve will do? Eve will get an access this computer, Ali's computer. Okay, that is one of the mandatory requirement because then only Eve will be able to perform the decryption. So what Alice will do? It will get brief access to Ali's computer, and it has only enough time to type two letters, right? So first time it types ET, okay, and it gets some result, and second time it types ET and it gets some result. So basically, it is typing ET for one algorithm and it is getting one result. And second time it is typing the same text for second algorithm and it is getting another response, right? So C then tries to encrypt short plain text using two different algorithms because she is not sure which one is the affine cipher, right? So algorithm number is not known. She is only knowing that there may be one of this as an affine cipher. So what happens? First algorithm, plain text of ET becomes ciphertext WC. Okay, and in second algorithm, plain text of ET becomes ciphertext WF. Right now, to find the key, Eve uses the strategy. Okay, which one is what is the strategy? Strategy is that Eve knows that if the first algorithm is affine, then E equal to W and T equal to C. Right. So what happens? That Eve gets an access to Ali's computer. Now, what E wants to do? E wants to know keys of affine cipher, right? Keys of affine cipher needs to be known. That means there are two keys, K1 and K2 needs to be known. So if E knows K1 and K2, then E will be able to decrypt the message which she has intercepted from Ali's computer, and that encrypted message can be decrypted. That is the goal, right? For that, Eve wants to know keys K1 and K2. So what Eve has done, she has typed ET character and found WC as the encrypted text. Now this is sufficient to find out the key K1 and K2. How? Let us see. So what we have to do? Plain text of E is 4 and ciphertext of W is 22. And plain text of T is 19 and ciphertext of C is 2. So from this we can write the equation, right? Because K1 and K2 is not known. So we can write like this. We know that K1 plus the value of the plain text. So in first character E has the value of the plain text, that is 4, right? 4 into K1 plus K2 congruent 22 mod 26, right? Similarly, in second case, we have 19 minus 19, okay? We have 19 K1 plus K2 congruent to mod 26. Okay, these two equations are written over here, right? Now what we do, we take subtraction. Okay, we take subtraction. So when we take subtraction, what we get? minus 15k1, and this gets cancelled out, right? It gets cancelled out. So minus 15k1 congruent 20 mod 26, right? So to find out k1, we have to multiply 20 by minus 15's inverse, right? Modular arithmetic, what we have to do? This, okay? Can you solve this? Can you solve this? Right? You can see 4 minus 19, that is minus 15, and k2 gets cancelled out. 22 minus 2 is 20, right? So what is this? Minus 15 is equivalent to 11, right? Mod 26. We can write like that. So 11 inverse is, what is the 11 inverse? Multiplicative inverse of 11. What is the multiplicative inverse of 11? So 26 and 11 GCD, if we take GCD of 26 and 11, what answer we will get? Right? So you can see that multiplicative inverse of 11 is, okay, again, simple method you have to apply. 26, 11. So Q, R1, R2, R, T1, T2, T. Okay. Then, right. So at that time, T value is 19. So are you getting T value 19? Have you done it in your book? So we apply extended Euclidean algorithm. Okay. Okay. So T1, T2, T1, 0, Q value. So Q value is for 26, Q value is, yes, anybody has found the answer? Yeah, students, are you doing it? Okay. Nineteen is the answer. Rikin is fast, very fast. Very good. Okay, please do it. And you should find that the final answer is 19. And so what happens? Your result would be like this: 19 into 20 mod 26, that is 380 mod 26. So it results into 16. Now, 16 is not having any multiplicative inverse in Z26 star. Is it correct? 16 is having any multiplicative inverse, right? So it means that this algorithm 1 is not affine cipher, right? Because if it is affine cipher, K1 has to be from Z26 star, correct? Is that correct? Got it? Right? So it means that this algorithm is not correct. I mean, not correct means this algorithm is not the affine cipher. We are doing crypt analysis. So what we do, we now perform next. Uh, so you will perform second attempt. So in this, you will try to result the second set of data. So in that, plain text of E is 4 and its cipher text is 22. T is plain text is 19 and cipher text what it receives is F. Okay. So now again we apply the same method, right? So you do try doing this for K1. So the equation remains same. Okay. Equation remains same. For K1 plus K2 congruent 22 mod 26, and the second one is 19 K1 plus K2 congruent 5 mod 26, right? And we take subtraction, right? So this gets cancelled out. So here we get minus 15 K1 congruent 17 mod 26, right? And so K1 is equals to minus 15 inverse multiplied by 17, right? And so that is equal to minus 15 is 11 inverse into 17. 11 inverse we already found it, 19 into 17. So 19 into 17 results into, okay, that you can see 19 into 17 results into 323. And do this exercise in your book. 323 mod 26 is 11. Find out the answer. 323 mod 26. Right. So when you get 11, it means K1 is 11. And so K1 is 11. K1 belongs to Z26 star. Is that correct? Right. So it is simple now. K1 is found. So we can find K2 also. So 4 into 11 plus K2 congruent 22 mod 26. Right. So K2 is 22 minus 44 mod 26. That is minus 22 mod 26. That is equal to 4 mod 26. And that is equal to 4. So K1 is 11 and K2 is 4. Is that clear to all of you? Right. So with these two keys 11 and 4, if these are encryption keys, right? So we have already captured this encrypted text. So we want to perform decryption, right? So this is your exercise that apply those keys and generate the plain text. Okay. This is your exercise. You should do at home. Is that clear to all of you? Any doubt, any question? Okay. Lab 3 reading material is uploaded. So you can refer to lab 3 material. Right? Okay. Have a good day to all of you.